In this video, I'm going to go through the instructions and give you some hints on the week 8 activity 2 worksheet. So we have marketing, and this is a systems of linear equation problem that we were working on earlier, similar kind of thing, where two lines, if they cross, they have a unique solution. In this one they do. So try this on your own, and then you can go through the video as needed. So we have a booth at a county fair only sells cotton candy. The following graph shows the supply S, how much cotton candy the booth is willing to make, and demand D, how much customers are willing to buy. For number of bags of cotton candy as a function of the price P that the booth decides to charge per bag. Now this is in function notation, so that just means this D with parentheses around a P doesn't mean D times P. It just means the demand at price P is represented by this line. So as we start up higher and go down, so it looks like as the this is the number of bags on the y-axis, and this is the price on the x-axis. So it seems as though from the data we can just kind of quickly infer that as the price increases, the demand drops. So the number of bags people are buying drops. And so let's look at the supply at price P. So as the P increases, this is the number of bags of cotton candy that are being supplied. So there's a sweet spot here right in the middle where they intersect. That would be the optimal price to charge, so that, because if they make too many, then that doesn't help them out, right? Because they'd have to put the price up and then the demand goes down. So we want to have it right in the sweet spot so that it's the best situation. So we're going to interpret this graph here. Let me get a little bit bigger. So what is the supply if the booth charges $2? So remember, our supply line is this one here that I'm highlighting with the laser. So if it charges $2, remember price is down on the x-axis, we can look up and see where it hits. And so we're going to go over to the left and look at the number of bags. So about how many would that be? These are in increments of 200. So 200, 400, 600, 800. So that's what you're going to do for this part. I'm not going to give the answer away. Kind of showed you how to find it. And then what is the demand at $2? So you're going to look at the same thing, but you're going to go up to this line and then look left to see the number of bags. Okay, so we're looking for number of bags there. So you can pause the video and just jot these down and do it along with, the instructions, or you can just kind of get some tips and then do it on your own. So the next question asks, what happens to the supply if the price is increased by $1? So for every, so you could just look between 2 points. Like, so if we are looking at the supply here, what happens when we change it, increase by a whole dollar, is going to be up to here. So just say what the difference is, how many bags difference that would be. And then the equilibrium price is going to be, equilibrium is when supply equals demand. Okay, so find when supply at price P equals demand at price P, or supply equals demand. Okay, and you can see that here at the intersection when they're going to be equal. At what prices will there be a surplus? So that means I made too many bags. So that's this area over here of the line, or not area, but the part of the line. That goes along with D. I'm going to kind of shrink it a little here so we can see the graph. At the equilibrium price, what is the booth's revenue? So that is a little bit tricky. Just got to keep in mind that you're finding the equilibrium price, which would be right in about here. You can just round off to the nearest, I don't know, 10 cents or something like that. But revenue is going to be the price times number of bags sold. Okay, so you can figure that out. You have to figure that out algebraically. And then profit is the next one. If the booth rental costs $700 and ingredients cost 30 cents per bag, find the booth's profit at the equilibrium price. So before we do that, we need to have the cost at the equilibrium price would be the cost per bag, and that would be times the number of bags plus the fixed cost, the startup or the rental in this case. So you can calculate that. And then once you get that, you can find profit by taking the revenue you found up here in E and subtracting the cost that you just found here. So if you want to pause the video, again, pause at any point, go back and kind of do them as we go. G is find the slope of D and explain its meaning using everyday language. So we're going to look at the demand, which is this line right here. And you know it's going down from left to right, so it's going to have a negative slope. So think about that. And then just pick 2 points, maybe this one and this one here, and figure out what your change in Y over your change in X. And we did some problems like that a little earlier in the term. You can also figure out, so that would give you your slope. And then you can also figure out the equation by using this y-intercept as well. Okay, so add that into the mix there, okay? You could do the same. It doesn't ask you to do this, but you could look at the supply and see what the slope is, but it would be a little harder to find the y-intercept because we don't have that there showing in the graph. We only have it over this domain of charging like $1.40 in there. All right, so I hope that helps. I'll write this up as a key, so you'll see that once the grace period for turning it in is over, you can have the full solutions. But I don't want to write it too much out because it's just really one number things. They're not too involved. It'll just give it away for you. But if you're stuck on something, feel free to email, ask questions, and to get that done. Have a great day.